Hey physics fans, today we're going to be talking about work, kinetic energy, and the work-kinetic energy theorem, which relates kinetic energy and work. Remember, work is done when a force acts on something through a displacement from one position to the next. It is equal to the integral of that force dotted with the infinitesimal displacement dr along the path AB. If the force is constant, it is equal to F dot d, which resolves to FD cosine theta if you remember your video on the dot product. Now let's say the displacement vector is going this way and the force vector is going this way. And the angle in between those vectors is 180 degrees. Well, that cosine theta resolves to 180 or -1, and then that equals negative work. You might be asking yourself, well, what's negative work? Well, that means the system has lost energy. Well, let's talk about that relationship later in my example, but for now, let's talk about kinetic energy. Kinetic energy is the energy of motion. It can be internal kinetic energy, it can be translational kinetic energy, or it can be rotational, but it's all talking about the same energy of motion. Now we're going to combine the two into the work-kinetic energy theorem, where the net work is equal to the change in kinetic energy. All right, so let's do an example to try to illustrate that fact. So if I exert a force on a block as it displaces from point A to point B, and drag exerts a force on that same block as it moves from point A to point B, we will have net work, because the force of drag is working in the opposite direction as I exert a force on that same block. Now let's say the block's final speed is less than its initial speed. Therefore, it was a negative net change in kinetic energy. Well, that means a negative net work, meaning the block lost energy. Let's say that the speed at B is greater than the speed at A, then it's a positive change in kinetic energy, meaning we have a positive net work change, meaning the block gained energy. What this means is that the work done by me is greater than the work done by drag. That concludes our video on work. See you next time. To the window, to the wall. All these problems solved. All these problems solved.